This is the new exciting thing that's coming out from Unirac. As we just went through, Unirac has great solutions for all types of flat roof applications, large, small, even saw a curved one there, a barrel roof. And those are really, those are base systems. All of the ones up to now at Unirac and then coming from Equilibrium are what we refer to as base systems, meaning that they are comprised of the bay and some clamps to connect the modules to the bay. And then those combine with the modules to build the array and create the structure of the array. Now, GridFlex is filling a gap that, just having the base systems, Unirac had a gap of not having a grid-based system with really the ultimate in structure for better load sharing. I'll explain what that means as we go through the GridFlex system. And the other gap that GridFlex is filling is to have a variable row spacing. So as you see in the system specifications, what we have available today is a south-facing 5-degree tilt with 2 row space options, 8 and 11 inches. And those can even be applied on the same building. So when we come out with GridFlex 10, which will be we'll be designing systems shortly here in the second quarter to supply in the third quarter, early in the third quarter. We're looking at August to have product available for the 10-degree system. That 10-degree system is going to have an 11, 14, and 17-inch row space option. So the same system, the same components can accommodate these different row spacings. And that allows you to meet the different goals of your project. So you might not be space constrained on one roof and be more space constrained on another, or even on the same roof, there might be a spot between a couple of rooftop units or a gas line pipe or something, even something unforeseen that we can use a tighter row space. So those are really the gaps that we're filling with GridFlex. One is to have the variable row space options. And then the other is we previously didn't have a system that had the structure that comes with rails running north-south and also structure running east-west. And we'll talk more about what that structure gives you. But what we're bringing here is a system that is lighter. So it's going to be lighter than typical base systems on most installations. Load sharing does require modules to be around the modules to share that load. GridFlex becomes extremely light the larger the array. So the larger the system, the lighter this is going to be. For arrays that are getting up to over 10 by 10 in the field, in the center of the array, we're seeing a lot of spots that actually require no ballast blocks. So we're seeing on the ballast plans a lot of 0s and 1s with the GridFlex system, and that's because of the structure, which provides excellent load sharing. And when we say it's faster, we're really comparing it more to the competing grid-based or rail-based systems that are out on the market. What we did with GridFlex was bring the install ease of the base systems that Unirac and Equilibrium are so popular and widely used with, bringing the base system install ease to a system that has the structure of GridFlex. And then more secure, we're going to show you what that looks like as we get into the clamps and what 3-point clamping means. So first we'll just walk through the components and give a little tour of GridFlex. This is the array with some clear modules so you can see everything there. The foundation of the system is a network of rails that run north-south. They are hat channel shaped. They're very robust compared to other grid-based low slope ballasted systems that are out there. There's a roof lander pad. This goes to that roof undulation question. There's a nice picture of these being stacked. So these are stackable for roof undulations. GridFlex does handle that roof undulation up to 5 degrees total angle change. But once it gets above that, you'll see the rails actually floating. It won't be putting stress on the modules like a base system might, but it will actually hold that structure. So you really will see very clearly when you need to shim a GridFlex system. The ballast tray makes up the east-west structure, and it is a superior east-west structure to our competitors in that it is a solid tray. It's not two pieces of angle running east-west. It's a solid tray that maintains that structure and keeps the system square. So you have the rails running north-south, and then the ballast tray, which also is fully containing that ballast block. So any crumbling or cracking that might occur over time, that ballast weight will still be in the tray and applied to the system. Then there's the south stanchion clamp, which we'll take a closer look at in a few slides here. That is a hinged clamp for module access, and it's a shared rail system. So that single clamp is going to mount one module on each side. And same with the north stanchion clamp, which we'll get a closer look at here shortly. That is where two modules will meet. And part of the benefit of the shared rail system is that it reduces the number of components required. It makes the install easier to do, easier to lay out, but also you have about half of the components and loose hardware compared to some of our competitors. The wind deflector is the final component. This is only used on the north edge of the array. It is not required in the field. The system has excellent aerodynamics due to the location of the ballast tray, which is essentially where the wind deflector would have gone. There's not that much space between the ballast tray and the north edge of the module. So that ballast tray does a great job of acting as a wind deflector, to the point where the added cost of the wind deflector, really you don't see the benefit in reducing the ballast. So it's a light system already. So we're only using those on the very north edges. So a little step-by-step kind of closer look into these components. This is the roof lander pad, which snaps onto the rail. And there you see, they can be stacked up to 4 for roof undulations. You get a little bit more than 3/4 of an inch every time you stack one of these. So that is kind of ample room to make up for those roof undulations, especially on the smaller, like we just did for example, an apartment building, where drains tend to be in the middle of the roof rather than draining out to the edges. And that gives you these points with really low points where if you didn't have these kind of shimmable bases, you might have to break the array there to account for the roof undulation. So some advantages here with the roof lander pad. It's a durable PC ASA resin, common material for outdoor applications like boat hulls or the casing on your car's side view mirror, for example, is using the very same material. So the rails are made up of modular sections. There's a south rail, a mid rail, and a north rail. And each row of modules, we're going to add 1 row of rails. So that also is an advantage here, applying the Bay system philosophy to a grid system. So the strength of a grid, but being able to build it in a modular process. So every time, if you have a jog in an array or a stair step or a module or a section that's missing, it's very easy to design this in a modular way and even change as you're discovering obstacles potentially that were not documented when the design was made. The way these rails connect, you see in the close-up image there, and it's a little hard there, it doesn't make out that great, but there is a scale for the module width at the 2 different row spacings. What's that is for is if you have a 39-inch module, or in real life it's going to be 39 point something point, let's say 1/6. This scale is in half-inch increments, and it allows the installer to repeat the measurement without a measuring tape. So if you have a group of installers, we just need to communicate what setting to put that at, and then they do not need to measure out anything as they lay these rails out. So that 39 and change module width, we would round that up to the 39.5-inch setting for whichever row space you were using, whether 8 or 11. And that way, right when you get up onto the roof, you can start laying these out without having to measure a single thing. And this also helps tell where those roof undulations are as you connect these rails. And that's just a single bolt that connects at the overlap. The next thing that you need to do once you connect these is space the rails out. And this is another advantage of the shared rail system. The main dimension that you need is a module width plus 1/4 of an inch. And that's going to be the space between rails at the interior of an array. At the exterior, we're going to bring that rail in 6 inches so that it's tucked underneath the array. And those are the only 2 measurements that the installers need to know to build this system. And it's recommended to build a jig, which I'll show shortly here too. And that way, when you are spacing the rails and you have that overlap scale on the rails, all you need, just like a bay system, is a straight line at the south edge or north edge. You could start either north or south, and then a chalk line at the east or west, just to keep yourself straight as you're laying these out and adding modules. So very minimal measurements required, just like a bay system. And this is an example of building the jig. We actually do this without a measuring tape with solar mount. So we take a 1/4 inch bolt and slide that to each end of the module that we're going to be using, and then just tighten that and make sure that what we're sliding to the module frame is the thread and not the nut, as you see in the picture there. And that 1/4 inch nut drops right into the 5/16 rivet nuts that are pre-installed into the rails. So you can use that 1/4 inch bolt, drop it right in from one rail to the next, and now your rails are spaced exactly a module plus the 1/4 inch on center from rail to rail. So you really don't even need a measuring tape to install this system. So once those rails are laid out, we're going to start installing ballast trays and placing ballast blocks according to the site-specific ballast plan. This is critical for any ballasted system, that you will have a site-specific ballast plan. It's important that it's followed with the exact ballast count for each location. And as we encounter obstacles, which is very common on flat roof systems, we want to redesign that so that we can appropriately ballast. So it's very important to communicate that back to us. So this is what the system looks like once the ballast trays and clamps are installed in their locations. All of those rails are pre-assembled with rivet nuts, so there isn't a loose nut that you need to install these things. And every component is installed with a single 1/2 inch bolt or 5/16 bolt with a 1/2 inch socket drive, and 1 bolt per part. So the south stanchion, north stanchion, deflector, ballast tray and deflector all are connected with 1 single bolt. And here's a close-up of those clamps, and to describe what we mean by more secure and the 3-point clamping. This clamp for the south stanchion that you see in the animation is supporting the module from the inside where the bonding happens, as well as from the outside, and fully supporting the bottom of the module for snow loads. So the strength of a module comes from the box of that module frame, and this clamp and the north stanchion, as you can see, are fully supporting any downforce that might be seen from snow loads. Another example or advantage here is as that module gets hinged down, and those are hinged for installees and also O&M access. And I mentioned the bond pin is in that south clamp. You can lay that down and have a really nice resting place on the north stanchion clamp. And you don't need to move that north stanchion clamp at all to tighten it. So once you're laid down, you can do your wiring. And then when you're done with your wiring, you can tighten the stanchion to both modules. And that north stanchion clamp also grabs the outside, inside, and supports the underneath of the module. So that's what we mean when we say more secure with the GridFlex system and this 3-point clamping. And here's an example of some wire management. We showed the Eco Tray. Eco Tray does run north-south underneath the GridFlex system. So it does fit underneath the ballast tray. It does not run east-west, the Eco Tray, but it is great for north-south. And here what we're seeing with wire management is an example of an optimizer for 2 modules and some props that the installers made to help take advantage of that hinged module action. So part of the the south clamp and having the bond in there that's nice is the whole time that they're working on this, those modules are bonded. They don't need to be fully installed, and each module, the bonding grid is totally redundant. So everything is bonded north-south and east-west. And this makes for really having the bonding in that south clamp that hinges makes it totally safe to be building and know that you are bonded. And then on the right, you see it's a nice clean look. There is nothing sticking out on the south edge like there are for all of our bay systems. Have a bay kind of taking up valuable real estate on the south edge. GridFlex is completely clean on the south along the east-west edges. And there's a very minimal amount, maybe 2 inches sticking out in the north beyond the north stanchion clamp. One of the install advantages with GridFlex compared to the base systems, I should mention, is the flexibility in process. So the GridFlex system, you can build the entire grid before you start laying modules, whereas a base system, you really are required, there's no way to build the racking without the modules. The racking and the modules really are one. Whereas the GridFlex system, you are able to build the whole rack and then add modules later. And that can help with any supply delays on the modules, which we certainly hear about. And this is just a close-up showing that bonding pin. So that is where the bond happens. And the bond is on both of those south stanchion clamps. So each module is actually bonded in 2 locations. And again, that bond is not broken if you're hinging that module up to service the optimizer or whatever O&M activity might be necessary. So that's the overview of the GridFlex system. I'll just quickly talk a little bit about the services we offer to support GridFlex and all of the systems. Construction drawing sets are free for you. It's something that you can take advantage of our UBuilder design tool to create designs, as well as leaning on our design team. So it's not just an online tool that's going to spit out a design for you. We have a team that can work with you if you have questions to check your ballasting, to create these construction drawing sets for you, and really create a package that you can go to permitting with confidence. And this is a rundown of kind of expected turnaround times. We do somewhere around 150 designs are turned out a day. It's a huge volume, and that is due in large part to our online design tool, but also we have a huge team of designers who are looking over these systems and working with you to, for example, get a PE stamp, which does have a little bit of a longer lead time. The site-specific PE stamp drawing is kind of the most in-depth and the longest lead time, but that's only 6 to 8 business days. So these are great turnaround times for you to first just get a bill of materials to get your quote so that you can go and sell your project, all the way through to construction drawings that are going to help you get your permit, and then the PE stamp that might ultimately be necessary for your project, and all with really great turnaround time. Part of the support and that Unirac commercial advantage is the ISS team. So this group here is our field training team, and we deploy them. We have, I think we're now up to 8, kind of 4 on each half of the country. And we really encourage installers and developers to take advantage of this service. It's free. It's something that we do to make sure that your project gets kicked off without a hitch. To overcome any questions, have someone right there to answer your questions. Each of these ISS team members have, I think they average about 10 years of solar experience, and that's really hands-on experience. So they've seen it all, especially with the Unirac products. So if you're using a new system like GridFlex, for example, we definitely want to get an ISS team member out to make sure that it goes smoothly. And all the questions are answered in an installation manual, but in our experience, installation manuals are maybe not the most common documents found on job sites. And it's great to have an ISS team member to, cut off that learning curve where there might be a question that would be answered in the install manual, and you can just turn to our ISS team member and ask that same question and get the answer immediately. Or if they're not there, of course, you can always call us or call one of them to get that answer immediately as well. So that commercial services department does offer the full support. If you want to look at a project with 2 different systems, if you want to look at it with EcoFoot 5D and GridFlex in a 5 degree, we're happy to do that and give you the full system layout and engineering behind it. You could compare ballasting, or if mechanical roof attachments are necessary, you can compare the counts from one system to another. So that's another advantage of having a racking partner that has the full suite, the full product portfolio for all the way from pitched roof through flat roof and ground. And it's really easy to get your quote. You can just provide us your layout, what module you're using, and then some pretty basic system information. And we realize that as installers are going to sell projects to their customers, they might not get all of this information up front, like parapet height, for example. And that's fine. We can work with you to get a design and a BOM out so that you can go and bid the project to your customer, and then follow up and make sure we have the right details. Structural capacity, that's a big one. How much weight can we put on the roof? And that's where attachments become necessary often, is that the roof can't handle the ballast weight that would be required to hold the system to the roof. So those are things that you may not have all of these details up front, but you can still get your project designed and get a BOM, and then we can work with you as that firms up. And I mentioned our field support. We've got great national coverage. We've got a lot out, focused on, of course, on the coasts, but we have great coverage in the Midwest too. And coming out of Albuquerque and Colorado, where I'm located, we have several people as well that can, so we have a wide reach, and we really encourage you to take advantage of the ISS field support team. But also we have account managers and regional sales reps all over the country to support you. At the beginning, we talked, or I mentioned the supply chain. Really large scale supply chain management is something that our customers really benefit from, especially right now, as we're hearing about, container ships being stuck in canals, and things being held at ports. And I know the solar industry, as well as all industries, have really been hit by the global shipping, something sort of a crisis, but it's definitely a situation. And what Unirac has done is really invested in inventory. So we have our average ship date is 6 days from order, which is due to the fact that we have this robust, diverse supply chain and the heavy investment in inventory, so that when you get your project and it's ready to go, we make sure we have product for you. And I mentioned GridFlex 5 degree is now available. We have plenty in stock, and that 10 degree will be available in August. But this gives you a kind of a map and gives you an idea of all of the work that our supply chain team has done to make sure that your supply and your projects are not interrupted. And also backed up by our ISO certifications, which I believe we're the only racking manufacturer with these certifications. The first one there is based on continuous improvement, and that really shapes our product development and manufacturing processes for continuous improvement. The second one is environmental considerations, to make sure we are making good use of resources. And then the third one is worker safety, which is of course an important aspect. So this ISO certification just kind of builds on Unirac's position as a trusted and reliable partner for you, and someone who you can rely on as a partner to get your projects built. Really protect your project's profitability as well. Make sure things don't go wrong. Make sure we've done the design properly up front with all of our experience and all of these million plus projects that we've supported so far in the last 22 years. So with that, yeah, I'll just invite everybody. Thanks everybody for joining, and learning about our flat roof portfolio and how we can really help you succeed in the C&I space. So please keep in touch. All of the things we touched on today, you can find on our website. And that Unirac U-Builder tool is a great tool for you to start designing and looking at, as you're getting into proposing a system to one of your customers. That U-Builder tool is a great tool for you to really quickly turn designs around. And if you ever have anything you can't do on U-Builder, you can always reach out to us and we can quickly turn those designs around for you as well.